Welcome back to Godot Dev Checkpoint. I'm Spaghetti Syntax, and today we are going to deep dive into one of my absolute favorite tools in Godot, Tweens. Now, if you ever wanted your game to feel alive, things that ease in smoothly, bounce a little, pulse, fade, or zip around the screen, well, Tweens are how you do that with pure code. No animation player, keyframes, or fiddling with the timeline editor. Just you and create Tween. The best way to learn to use Tweens is to use them for real. So that's exactly what we're going to do today. Today we're going to build a game called Tween Flip. It's going to be a playable card memory game where every single animation you see is going to be powered by a tween. Now by the time we're done, you'll know every major feature, tweening features, tweening properties, chaining sequences, running things in parallel, callbacks, intervals, looping, and cleaning up when things go wrong. Now a quick shout out to our newest scene instancer on Coffee, Burton, and on Patreon, a couple new free members, Francis and Van Ty. Now, your support keeps this channel going, and I really appreciate every single one of you. Your support is super generous. All right, now let's build something. Here's our goal for today. A working card memory game built from scratch in Godot 4.6, and by the end, you'll understand tweens well enough to use them confidently in any project. Let's go. Now, first things first, I'm here in a new project. I'm just going to call mine Tween Tutorial. You can call yours whatever you want. I just use the forward plus renderer. We put it in the location easy for you to find. Now, let's talk a little bit of architecture before we touch a single node. We're going to build two scenes. First is going to be a card scene, a single card that knows how to flip itself. The second is going to be the main scene, the game board that's going to hold all the cards and runs the match logic. Now, this is good Godot practice. Each scene has one job. Now let's start with the card scene. Already in a new scene. We're going to create a control node scene with user interface. Control. We're going to rename this to R. In our layout over here, make this a little wider. Our custom minimum size is going to be 100 by 140, the size of a card. We're also going to change it in our transform size. It's going to be the same as the custom minimum size, 100 by 140. Now we have a card here. Now let's add two visual layers of a card. Every card's going to have a back, the side that hides the symbol, and the front, the side that shows it. We're going to use color recs for both since we're not using any art assets today. The important thing is the concept, not the pixels. So the card's selected. We're going to right click, add child node, color rect. Right there. We're going to rename this to card back. Then we go to the anchors here. We're going to set it to full rect. It takes up our whole section that we set earlier on card. We're going to change the color here. We're just going to use a color blue so we can pull this down, take this green out. There you go. Nice dark blue. All right, then you can do card selected again. Right click, add child node, use another color wet. And this is going to be the card front. Same thing here. We're going to set the anchors to full rect. The color, we're going to use kind of a cream-like color. We can use the FAF 3.0 edition of the setup. Yeah, it's a nice cream color. It's perfect. We're going to hide this front because we're going to be able to see the back. Then we're going to flip to the front. So with this eyeball here, just deselect that. So we just see our back. Go and save that scene. Just save in our work folder for now. It's named card. That's fine. Go and save. The front needs a label to show the card symbol. Now, a card without a symbol is just a rectangle. And we're going to build a game, not just some abstract thing. So with a card front selected, we'll actually unhide that so we can see what we're doing here. We're going to right click, and we're going to add child node label. Enter it there. We'll rename this to symbol. And I'll set the text to a question mark. We'll set the horizontal left and right to center. There we go. So now our text will be centered. We'll set this anchor to center as well. Then we'll scroll down to our theme overrides here. Notice we can't actually see it, so we need to change the color. Change the font color to a darker kind of tone, not extremely black, but we can use something like 494949, just like that. We also need to make it bigger. So our font size, we'll change our font size to 48. There we go. There we go. Nice, soft black. Our card scene should look like hierarchy card, card back, card front, and then symbol in the card front section here. We'll make this hidden again so we don't see the underside of the card. All right, now important step, do not miss this step. We need to select all of these, card, hold down shift, click symbol, and they'll all be selected. What we need to do here is set our mouse filter to pass. You want to pass through all through the symbol all the way to the root node card. We'll explain more why here when we get into the code of that. Just make sure all your card nodes are set to mouse, filter, pass, propagate up. All right, and go and save that scene. Perfect. Now let's set up the main scene, the game board. Since we're using just UI, same as applies to this card. So scene, new scene, control root, and rename it to main. So scene, new scene, user interface, control, rename it to main. And make sure our anchors are full rect. Should already be. There we go. Then we need a grid container that holds our cards in a nice 4x4 grid. So we're going to add a child to the main, right click, add child, grid, container. Okay. Now rename this just to grid. And set the columns in the inspector. We want it forward. Now we set the anchors here to center. Right here. It's right in the middle of the screen. On the layout here, we're going to set the layout here. I set the custom minimum size to 448 by 608. It's going to keep it nice and contained in the center here. To make sure your anchor is on center. Now down in the theme overrides, we have this thing called constants. Now what we want to do here is we're going to actually have some separation between the cards when we spawn them in. And the separation we're going to use in the horizontal and vertical is 12. I found that to be a nice separation between each card. I also need a win label and a restart button. We're going to hide those by default, and we'll wire them up later. So in our main, we're going to add child node label. We'll call this the win label. Just keep it in the top left here. Just say, you win. There we go. Make it bigger in the theme overrides, fonts. Remember the font sizes. We'll just use something like 64. Right, now we'll hide that. Then we also need to right click main node again, add child node button. There we go. We're going to call this the restart button. Like that. And then we'll put this in anchor bottom right there. On the text, we'll just say play again. Great. Save that. And set the scene as main is fine. We'll send the root folder for now. Save. Our scene structure is ready. Part one is pretty much done. So let's write some code and start using Tweens. Just don't forget to hide this restart button. Let's save that again. And then back at our card here, with our card selected, we're going to attach a new script. We're not going to use any template. We'll just clear that out. We'll keep it nice and empty. So card.gd, that's perfect. Create. Now we have a just extend control and nothing else. I'll make this bigger so you can see it. Zoom in a bit. First, set up some variables and signals. We'll try to explain them as we go. The first one is going to be a signal. It's going to emit when the flip animation fully completes. Now, how do we do that? Signal. Have you seen my video on signals? It's going to be really helpful to figure out what these do exactly. If you're not sure, if you've never seen signals. For now, we're going to say this signal is card flipped. And it's going to be card type control. And then we also want another signal. We want this to emit when the player clicks. So when the player clicks, and hey, that signal, we're going to call this one flip requested. Where the player is requesting to flip this card. Send it here. It's going to be a card type control. The symbols we're going to use, we're just going to use symbols through text like emojis. That's the easiest for now. You know, as replace with whatever you want to do in the future. So it's going to be the symbol here is a variable. The symbol this card is hiding. Now it's going to be just a normal variable symbol. I'm just going to use strings. So it's a type string. Initially, we're going to set it to blank. We're going to say, hey, is this card currently showing? Is this card currently showing? I do that by just saying the bool. So var is face up. We're going to set it as a bool. We're going to set it to false initially. We also need to check if the card has been matched. Has this card been matched? So, and then matched cards can't be flipped again. So we're going to use that bool here to check if it is matched. So it stays face up. So is matched bool. Let's start as type false. We also need to store the active tween so we can kill it if needed. So the tween's playing and we need to get rid of it. So this is going to say, hey, this tween is playing. Get rid of this before you start a new one. So store the active tween so we can kill it if needed. Kill it if needed. So new var, it's going to be tween. There. It's going to be a type tween. We're set it to null initially, which means it's empty. Look it down. Let's save this script. I'll make this smaller here. And we need some references. So these are going to be the node references. Node references. We need a reference to our card back, front, and the symbol. So you can take our card back, drag, hold down Control, and drop. And then we have our on ready here. We also need the card front, Control, drop. We have our card front and our symbol. Drag, Control, drop. Whoops. Let's change this to symbol label. Be more definitive about it. Symbol label. We just change this to symbol underscore label. There we go. Now we don't have the naming error here. We don't have this variable to be same as this variable down here. Go ahead and save that again. We also need to make sure our card front here. So we can delete this reference. You got to make sure this reference actually matches. So we could just click, drag, do not hold Control, and just drop it normally. And they'll actually populate our reference correctly. Say that again. Now we're going to add the ready and the setup functions. Now, three things are going to happen in the ready. First, we set the pivot offset to the center of the card. That's going to be half of our 100 by 140 size. Without doing this, any scale animation that grows from the top left corner is shoved into the neighboring grid cells, which looks terrible. That's why we're going to center it. And then we need to make sure the mouse filters on the child nodes are going to be set to pass through code. So it's kind of a check just in case. So it can reach the card root. Says if you don't have that pass on the the symbol or the card front, that click's not going to reach all the way down into the card, which we needed to. So in input blocking is basically what that's called. But crucially now, the pivot is critical to set up now before we ever animate anything. So back here, there's a script. I'm going to enter down a couple of times. We're going to start this ready function, ready. Tab to autocomplete, enter down. The first thing you do, you just set that pivot to the center. Set pivot to card center. And this helps with scaling animations. Okay? So we gotta spell right, animations. So they grow from the middle and not the top left corner. So the pivot offset for our card is half of our 100 by 140. So the pivot offset is going to be vector 2, 50. So 100 divided by 2 is 50. And the 140 divided by 2 is 70. We know that is going to be the middle of our card. We're also going to, through code, allow clicks. We set this up in the inspector before, but now just in case, we're going to allow clicks to pass through child nodes up to the card root. This is double checked. Without this, the color X will absorb clicks and the cards never get to see them. So we'll say card, back, mouse, filter. Mouse filter, ignore. Mouse, filter, just that one, equals, control, mouse, filter, pass, right there. So we need that with all of our card back, card front, and symbol. So card front, filter, mouse filter, control mouse dot mouse filter paths. So that, then the symbol label, same here, mouse filter equals control mouse filter paths. There we go. Save that. Now in our setup function, enter down a couple times function, setup, it's going to be of type string coming in through. So our symbol text, we'll call it sim, should be string. It's going to be return type of void, colon, and then our symbol here. So our symbol string here is the card, what it's hiding. So what emoji we're going to use to match. So this symbol is going to equal this sim here that's going to be passed into it. So symbol equals sim. And this will be our symbol we're passing into to populate onto the card. Let me change the symbol text, symbol label, text into the symbol as well. So we can actually see it. And now we need a way to see if players clicked. So we enter down a couple of times. We're going to use the GUI input. So function underscore GUI input over here. This is what we're going to use, autocomplete there. Always autocomplete if you can. Prevent typos. I'm very prevalent with. So in our input event, we can detect our clicks. We need to say if the event is the input event mouse button. So now we know that the mouse button's been clicked and the event mouse button has done is pressed. So if the mouse button has been pressed, well, first thing we want to do is check if a player is clicking on a face-up card or a matched card. If there is, well, we need to guard from that. So this is going to be our guard. The guard from player clicking on matched or face-up card. How we do that? We say, well, if is those bools we made earlier is face-up or is matched. So either of those things are true, we just want to return. We don't want to go into this at all. We want to flip the card again. Now here we're not going to call a function. We're going to set a signal. So who's ever listening to that signal is going to call whatever function they want. So it's going to be don't call function ask signal to emit. And how we do that? We say, well, the flip has been requested. So the flip requested signal that we wrote, we want to emit that to ourself because we are the card. We want to admit that the flip has been requested on ourselves. Just like that. Go and save that. Now, the moment we've been all waiting for. Let's write our first tween. Now, here's a mental model. A tween is like a playlist of animations. You create the tween, then you add steps to it. And by default, they're going to play one after the other. Each step says change this property on this object from this value to this value over this many seconds. All right, I'm going to add you down. And we'll add that flip function, flip. Now it's going to be a type void. I don't return anything. The first thing we want to do is we don't want to flip a matched card. So another guard here. So if is matched, well, return. We're not going to flip it at all. The first step into tween is to create a tween. So the first thing to do is create the tween. Create the tween. Okay, that's going to be easy. This Godot 4 makes it super easy for us. We're going to store it in a tween. The variable we wrote up here, scroll up. See, here is our tween variable we set to null earlier. Now we're going to create a tween and put the tween in this variable. Tween equals, well, super easy, create tween. That's it. Now we've created our first tween. We'll store it in a variable here. The second thing we need to do is we're going to fake a 3D flip by squishing the card's scale on the x-axis down to 0. So how do we do that? Well, we're going to squish card x-axis down to 0. How we get? Well, we use our tween that we just stored, and we access the tween property. In this property, we need to say what we're doing to, or we're doing it to ourselves. And we need to access what property. And it's going to be scale. And the scale we want to access is the scale, colon, x. Now we're accessing our x-axis scale. And then we need to set it to what we want to go to. We want to go to 0. And how long will it take to get there? Well, 0.2 seconds. So not slow at all. Pretty fast. To explain that, we'll do the tween property here. So we have it commented. This first thing it's going to be is the object, property, path, final value, then the duration. Just like that. We have it squishing. Well, we need to reveal the other side of the card, right? So we need to stretch it back out. Stretch back out. Now this is going to run sequentially. So after this is done, then this will be done as well. Kind of like when you're doing awaits, if you're familiar with those. Once again, just the tween property. And back to our self. Once again, we're accessing the scale X right there. Then we also need to say where we want to go. We're not to 0. We're going to go back to 1. How long will it take to get there? Well, the same amount of time. Don't need that in the parenthesis there. Now we're going to stretch back out with this tween. Great. Let's save that. And since we have that all cleaned up, let's actually go and break our rule here. Now we're going to call this function directly right when we click. So underneath our flip requested, we'll enter down a couple times. Just for testing, temporary call. We'll call it flip. Just temporary. Temporary call. Make sure you delete this. So say use the to do. It's going to be delete. There we go. To do, delete, temporary call. We're going to do this so we can test it. And we're going to save that. I'll make this smaller. Go back to our 2D scene here. Make sure in our card scene. Right there. I'm going to take the card. I'm using the move tool here. I'm just going to move it to the middle of our viewport. So we see it. And then if we press F6 or just this little scenery icon, click on that. And we test our click. There we go. A nice flip. Now you see that? It squishes and comes back. That's right. It's your first tween. Now it's 2 lines of code that animate and property over time. No animation player, no keyframes, just create tween and tween property. But notice something, the card just squishes and comes back. It doesn't actually flip to reveal anything. We'll fix that in the next part with chaining. But first, we're going to talk about something that'll make this feel way better. Easing and transitions. Now, right now, our flip uses default motion, which is linear. Now, everything moves at a constant speed from A to B. That's fine for a robot, but not a game that should feel alive. Now, Godot gives you 2 tools to shape motion: transition types and ease types. Think of them like this. The transition type is the overall shape of the motion curve. Now, is it smooth like a sine wave, or does it shoot like a spring? Or does it ease like a car accelerating real fast? Now, ease type controls which end of the animation gets the emphasis. Does it speed up at the start, at the end, or both? Now, let's go ahead and do this together. Now, in tween property, you can chain 2 method calls: set transition and set ease. Let's write some code. Now, back in our card script here, we'll add to our flip function. Now, in our actual squish here, we do after our tween property, we have this. Now, to make it so it's not linear, like we just talked about, we want to actually accelerate smoothly or in a sine wave, which we're going to use the sine. So what we do here is space. We'll use a backslash to make a longer line. Enter down. I'm going to tab forward. Let me use a period here. That's going to continue our line. We want to use set trans or set transition we're going to set the transition to the tween. And what we're going to use is a trans sine. So the transition we want to use is a sine. We're going to use a trans sine wave. And you'll see the difference here in just a second. Now, space, we're going to make another line. So backspace, enter down, use the period. And we're going to set the ease. So the ease we want to use, we have the transition. Now we got to say the ease of what you want to do it in. So since this is the squish, we want to use the ease in. So tween dot ease in. Just like that. Now that we have that set up, we will just set the stretch back out. We just really have to do the opposite here. Instead of ease in, we're going to use ease out. We actually copy this up to the back slash there, Control C, and space and Control V. Then we have we're going to use the same transition, the sine wave. And instead of easing in, this one's going to ease out. So like that. So stretch back out. Going to save that. Great. Now go ahead and do what we did here. Same as we did. Make sure we're at 2D scene our card is center. And we can make this smaller so it looks like yours. Or run the scene again, F6, or this film roll, click. Now check out the difference between this one. Oh, it eases out and in. Ease in, so it goes faster at the end. And the other one goes slower at the end. That might be tough to see right there, but it does feel better. And to check that out, difference, we go back to our script. And then we Control K that. Whoop. Control K these. Yeah. Get rid of that. You don't have to do this part. Let's go ahead and do an example. And save that. Run the scene again. And see how it's just the same all the way through. If you use these transitions. Okay. Yeah. And Control K, save that. Tell a nice flip difference. Really does look a lot better. And it gives your game feel. Instead of being robotic, this is more of a natural feel to it. The player will notice. Even if they don't notice what they're noticing, they'll notice it just looks better. That's the difference between a prototype and a polished game. Now, let me show you a few other transition types. You don't have to do any of these. We're going to stick with sine. But for example, I'm going to show you the ones we can do. And here's some transitions you can try. So you're using the sine one. So it's a smooth, natural motion like the sine wave. You also have bounce. So it's a rubber ball type landing used for things usually land, not really for cards. Now this is what bounce looks like. Bounce, bounce, bounce. You also have the elastic. So it's like a rubber band overshoots and springs back, almost like a cartoon. Now this is what that looks like. A little shake, shake. You also slow these down or make them faster to your heart's content with the 0.2. Now this is the back. So it's a overshoots, then settles down. Get that big. Like that. It stretches out and zooms back in. Just like that. We want our cards to stay consistent size, so that one doesn't really work for us. And then we also have a linear. The important with here is it actually is basically the same as we did first. So we actually need to remove the set ease if you want to use this linear. We've already seen that. That was the first one we did just without the transition keyword. If you tried all this, I'm going to stick with the sine. I'm going to replace this back with sine. I'm going to stick with that one. Save that. Make sure that still works intended, just like that. I think that looks really good. Now, a quick note, the Tween class has a lot of transition options. Trans quad, cubic, quote, expo, circ, they're all different mathematical curves. So you can look them up in the Godot docs. I'll have them linked down below. And there are great visual comparison tools online if you want to look those up. But for today, sine and back are your two best friends for the game feel. We're going to use sine. So keep it simple.
Now, right now, our card squishes and comes back, but it never actually changes the face. Now, a card flip is going to have two phases. We're going to flip to the midpoint, swap what's visible, and then flip back out. Now, it's a classic two-phase animation, and tween chaining is exactly how we can accomplish that. Now, a key insight about tweens, every time that you call a tween property on a tween, you're adding a new step to the sequence. They're going to play in order. So 3 calls means 3 steps, one after the other. That's chaining. Now we need to add that middle step between the squish and the expand. It's going to be a callback. A callback is a function that runs at a specific point in the sequence. Now we'll introduce a tween underscore callback. Now we're going to cover callbacks a little more in depth in the next part, but right now we can use it to swap our card face exactly at the right moment. Back in our script here, in our flip function, we'll make this bigger. And then right between the squish and the stretch, we need to add that middle point like we are talking about. So exactly at the halfway midpoint, what we want to do is swap which face is showing. We're going to do that with that tween callback. So underscore tween. So our tween that we stored, we're going to use a tween callback. It's right there. And what we want to do in this callback is to run a function. And the function we're going to write that we want to call, we're going to call it, well, swap face. So you want to swap the face. Swap underscore face. And you don't need callbacks, kind of like what we do when we initialize signals in a ready function. We don't actually use the parentheses on the end of this. We don't want to do this. We want to do without the parentheses. So now we have this swap face here. We need to actually write the function. So we'll scroll down. I'll go above this transitions to try. We're going to write the function called swap face. We need the parentheses here. Return type void. And in this function, what we want to do is check if it is face up, make it not face up. So we just want to do the opposite. So this tween is going to check if the card is already face up. So like if the timer, how long we want to show the face up has expired, what we want to do is actually make it not face up. So the opposite. They want to tell it what it actually means. What that means is the card back dot visible. Well, when we reach that midpoint, we want to hide and show the proper side. So if the card is not face up, then the card back would be visible. So if the card back dot visible, then the card is not face up. And the opposite is true with the card front. So the card front, if the card front is visible, well, that means the card is face up, just like that. So this is called at the midpoint here. So we'll call that midpoint of the flip to swap which face is visible. So the magic here is the timing. The callback fires exactly at the moment the card is right on the edge. So 0, 0, which means it's invisible to the player. So the face swap looks instant because we can't see it happening. Now, it's a technique used in real card games, real UI animations, and real polished games. So basically, it's just a fake it till you make it kind of thing. Let's save that script. And make sure you actually spell visible correctly. There we go. Then, in order to test this with our face up now, we have this guard up here. So if face up in our GUI input here, if face up, well, we want to return. We don't want to do that now. We want to actually click on it. In the future, we're going to introduce a timer and have it flip automatically. So we're going to let the player actually click a face up card right now. So we'll take this card and we'll highlight it in Control+K. We'll comment that out for now. All right. And then we're going to save that. And then we can go and give this a test. So we can check out our flip animation. F6 will run current scene. You record now, we flip once, and then we flip again. So now we have a complete transition. Now we're going to actually set up, so when we click here, it's going to start a timer. If we have 2 selected, it's going to check if it's a match. And if it's not a match, it's going to flip both the cards back. That's why we'll have that guard there, so we don't have the player able to spam click like this. Because you notice this isn't very player friendly. I'm going to actually just click once and not let them click again. until the timer runs, and then only let the player click when it's the card back. So now we know our animation works. We can actually take our guard and turn it back on. So we highlight this again, in the GUI input, Control K, to bring this back online. And go and save that. You'll see a difference here if we run the scene with this activated. Play the F6. We can click once and flip it, but if we click, now nothing's going to happen. Just like that. So we want that because we want to have a player click card, then click another card. I'm going to make them stick with their choice that we had. The timer is going to flip these cards back as soon as they check if it has a match or not. Now that we use tween callback in the middle of our flip, we can talk a little bit about why it's one of the most powerful tools in the tween arsenal. Now, the problem it solves is the animation and logic need to stay in sync. So in games, things happen after other things. The card flips, we check for a match, the explosion plays, then we remove the enemy, the door opens, then the player can walk through. If you just call your logic function straight away, it runs before the animation is done. Tween callback lets you say, run this code exactly here in the animation sequence. And right now, our flip function doesn't tell anyone it finished. The game board has no idea a flip even happened. We need to emit our card flipped signal at the end of a flip animation. Now, this is the job of the tween callback. Now, we'll also restore the card's click detection here, but more on that on a later part, which is when we're going to add input blocking during animation. So back in our card script here, in our flip function, after our animation has finished, so after we stretch back out, what we want to do then is actually restore the click detection and tell the board that a flip is done. So here, we're going to restore click detection and then tell the board if the flip has finished. The flip is done. That works. So we're going to take our tween we stored that we're using here. Then we use the tween callback like we said here. And then in this callback, we're not going to make another function like we did with the swap face. We're actually going to do what's called a lambda. Now, lambda is like a tiny inline function right here. You can also write this as a separate function, but the lambda is going to keep this nice and tight. So how do we do that? Well, we do the function inside the parentheses here, and then the colon. Then what we're going to do now is we can actually enter down, and then we're going to use mouse filter. This is the restore click detection equals control mouse filter stop. So we're going to stop filtering the mouse. Then after that, what we're going to do here is say, hey, we've done that. So now we want the card flipped signal to be emitted to ourself. It'll take this parenthesis and drop it down there. And then back here, just to make it look like proper function. Let's save that. This is a really nice contained way to actually just have a function within a callback. I said you could write this function as separate like this if that's easier, but this is a nice way to keep it nice and tight. Now we're going to build the main GD script. Now this is where the flip requested signal architecture is going to pay off. Now the idea behind that is the card never decides whether it's allowed to flip. It just raises its hand, I'd like to flip, and the main decides yes or no. Main is the signal gatekeeper for all the flip decisions. They're back in our project here. I'll make this smaller. What we need here is to go back to our main scene here. In our main node, we're going to attach a new script. We're just going to call this main, use the empty template, and then create. And then we have this extends control with an empty script. Go ahead and save this, get that out of the way, then enter down. Now we'll say this next part for the main script has nothing to do with tweens specifically. So I'm going to go through it pretty fast. So we're not going to explain much of the code behind it. Now, if you want to skip back to the tween part, I will have this up on my GitHub so you can actually copy and paste this script itself. But if you are interested in how the game part is built, not just the tweens, so we go ahead and stick around. If not, there should be a chapter selection on the video itself. You can skip to the next tween part. It'll be after this one. And you can copy and paste the script from my GitHub. Be linked in the description. For those who want to follow along, let's get writing. Let's say we're going to go through this pretty quick. I'm not going to explain every single line of code here because this is mainly just a tween video. So the const card scene, but we need to actually load that scene. And we need to load that card scene with the card string there. We're going to use const for these. And then we want symbols for the actual cards. We're going to use an array of strings for those. We use emojis. The emojis we're going to use some fruits. And then how do we do that? We do the brackets here, angle brackets. The fruits I'm going to use are some fruits I found Google. Just going to copy and paste these here. That's that. So I'm going to use a apple, banana, grape, strawberry, cherry, orange, kiwi, and a pineapple. Let's save that. So next, I'm going to need the flipped cards that the player has actually requested. So the cards the player has requested to flip, we're going to do max 2 at a time. Yeah. I'll make this bigger. There we go. So the flipped cards variable is going to be another array, array of control, since we're using the UI. Then that's going to be empty, initialized initially. So then we're going to track how many flip animations are still in progress. Okay. So the pending flip, and we're going to use the int for that, and 0. Then we also need to track the matched pairs. That's also going to be a 0 int. There we go. I'll not actually let any more flips happen. So it's going to be kind of a lock. So it's another guard. It's going to be when false, no new flips are going to be allowed. Use a var. So can flip is obviously going to be a bool. We're going to set it to true initially instead of false. We'll set it to false when we're actually our max flips allowed. We also need some references to our grid and drag and drop. We'll have control. We also need our win label, drag drop control. And we also need our button, drag drop control. There we go. And in this, we also need the ready function ready, tab autocomplete. Now in this, we want to actually set the win label initially to hide it. So we use the false when it's visible. And after our win label has been hidden, well, we want to actually set up the board, the grid board. So we're going to write a function called setup underscore setup board. And go to write that function now. Function setup board, return type of void. Then what we're going to do here is actually write a loop for the children in the grid. So the for child in grid dot get children, then child dot queue free. So initially we want to actually clear the board. So we set up a new one. We also need to actually, after we queue free, we want to set all the matched pairs to 0. Then we want to actually clear the flipped cards array like that. Whoop, just like that. And now we want to actually change the pending flips to 0. So just resetting everything basically. Then we set back can flip back to true. And then we want to set the win label back to false. So when the setup board is called, we also hide this. This will be good for when we push the button. So it's not just when this game starts, it's also when we push the restart button, we're going to hide that win label again if it's visible. Then we can just set up our symbols array. Our symbols, we array string. And it's also going to be, empty initially. When we set up the new board, we're going to reset our array. Symbols dot assign. We're going to use the symbols constant that we have up here, right there. We're going to assign symbols plus symbols. That'll give us 16 cards and a match. So we want one of each, one there, one there. Then we'll have one of each fruit, and then we'll be able to match them. So it's going to be 16 cards total. There we go. Then we're going to shuffle it. So we don't want it to be the same every time. So I'm going to shuffle that array. Then we want to actually show the cards. So for for each symbol, this will be a check string in symbols array. We do here, we put the card temporarily in a variable. Type control, this is the UI. So we need the card scene that we packed earlier. All right, instantiate just brings it into being. So it doesn't have instantiate. Oh, use the card.gd instead of the actual scene. Well, that's silly. Let's make that bigger. Then we need to go back up to our preload. We want to use the actual GD script. We want to actually use the scene. So we want to make sure we're clicking on the TSCN, not the GD. There we go. Now we have our scene, which now we can instantiate. You can't instantiate just the script. Now after we instantiate the card, we want to add it to the grid. So grid.add child. This going to be the child we want to add is the card that we just instantiated. Now we need to actually set up the card. Card.setup. Let's go back to our card script here. Scroll down. Just for consistency's sake, we actually remove this setup here. The underscore. The only underscores in the front should actually just be the ones included in the engine, not the ones we write ourselves. Let's save that. There we go. Now go back to our main. Then we're going to use the card.setup. There we go. Then setup we want to use is, well, the symbol. Oops, I spelled setup right. Is the sim. For each symbol in the string of symbols, we want to set up the symbol that we have on this index point. And then we need to connect both the signals. So connect both signals. And then we do that card. Then we do flip requested, and then we're going to connect that flip requested to a function we're going to write, which is going to be called underscore on flip requested. Just like that. And no parentheses on the end of that. We also need to connect the card flipped signal. Just like that, card flipped. And we're going to connect that. And it's going to be another function we're going to write called underscore on card flipped. Like that. Oh, wait. No period, underscore. Just like that. And save that. Just a review up here. Child Q3. What this is going to do is going to remove any existing cards. Just like that. And then after that, we're just going to reset the entire board. And then here, going to build the list. Build list of symbol pairs. And shuffle. And then after that, what we're going to do here is instantiate a card for each symbol. Just like that. Now, going to save. First thing I'm going to write is the on flip requested. So you have to do that a couple times here. We do function on flip requested. And that's going to be think of a parameter type card, control, type control, then return type void. Right. And in this on flip requested, first thing we want to check if not can flip. So if it can't flip, well, we want to return that here. Because if the flip request says you can't flip, well, you can't do anything after this point here. So then what we want to do is we're going to track this card before the animation starts. Yep. There we go. Or you just put it in the flipped cards. We're going to append that to that array. Type card. The one that we passed in here, card, goes into this appended to that array. And then we're going to add our pending flips plus equals to 1. And then we're going to call card flip. So we're going to call that card flip animation. Save that. Before I forget, go to our card, go to our flip here. Well, we don't want to call when we click flip, we're going to delete this section here. So our GUI input and our card GD script, we're going to delete that there. And save. Back at our main GD script. Now we want to check if we have 2 cards flipped. And if we do, we want to lock the board so the player can't flip anymore until the current cards are flipped back over. So basically, it's going to lock the board the moment 2 cards are flipped. So we say if flipped cards is the size of that is greater than or equal to 2, well, we want to say can flip is false. Simple as that. Let's save that. Basically, all this on flip request is doing, well, it's saying the card has to flip and the main's going to decide if that's allowed. So card asks to flip, main decides if that's allowed. So now we need to write the actual on card flipped. So we know the card has been flipped. Animation is done. So we'll enter down here. So there's going to be a flip animation as finished. Check. Or match. So the function we're going to write, function on card flipped. Same here, we're going to pass in the card, type control, and return type of void. Make sure this on card flipped here matches our on card flipped in our connection. All right, now that we're in here, so we don't want the system actually checking if a card that we just clicked is still in there. If it's not face up, we don't actually want that to have any comparison. So if the not card that it's being passed in here, if it's not face up, then we need to get out of here, return. To have a safety check, say, hey, this card's not face up. We shouldn't be checking if it's a match. And so after that, make a note of that. Say if not face up, ignore. Right now we need to go after our if statement here. What we want to do next is check the pending flips. And we're going to use the max pending flips from 0 to, well, the pending flip size, pending flips 0. No, not 0. That's the next line. -1. So to make sure our pending flips don't go outside the array, the bounds. Then we need to actually, after we have that, we need to check match only when both cards are done animating. How do we do that? Well, we say if flipped cards dot size is equal to 2 and the pending flips is equal to 0. So no more pending flips. We know we have 2 cards flipped total. Well, now we're going to write a function called underscore check match. In parentheses, go and save that. Right. Let's get into the check match function. Function check match. It's not going to take any parameters, return type of void. So the first thing we need to do is check between the first card and the second card. So for card A, temporary card type control. And then the flipped cards is going to be the array index of 0 is the first one. And the second one for card B is going to be type control. And it's going to be flipped cards index of 1. Then we got to spell control right. There we go. So then we say if the card A symbol, array dot symbol, is the same as card B dot symbol, Well, now we want to say it's a match. So we want to increase our matched pair by 1 plus equals 1. And card A is matched. It is underscore matched equals true. Great. We also want to say is card B dot is matched also equals true. There we go. And we have those matches. Now we want to actually clear the flipped cards. Flipped cards dot clear. Get those out of there. So we can set up for the next one. Then we're going to say, can we flip some more cards? Yes, we can. So we're going to change that to true. Now I want to check if we have all of our matches. So if the match pairs is equal, match pairs is equal to the symbols dot size. Well, we want to actually write another function called show win. And we're going to actually make that function here in a second. Let's save that. We're going to enter down first, adding else to this. So if we don't have a match, no match, we're going to actually flip back. Flip card back. There we go. So we're going to stick card A. We want to call the flip function and card B, card B, flip. There we go. And then we also want to flip the card or clear the flipped cards array, just like that. And then we also want to say, can we flip again? Yes, we can. We didn't find a match. We flipped all our cards back over, cleared our flipped array. Now we save. And then we can write this show win function here. Enter down a couple times. Function show win. Return type void. All this is going to do is we're going to show that win label. Win label visible equals true. Great. And then save that. We also need to connect our button. So we can go back up to our ready function here. Ready? Boop. There we go. And underneath our win label visible, we can do here, we're going to write the restart button. Restart button. Pressed function. We're going to connect that on a function called on restart button pressed. There we go. And we need to write this function. So we take this, Control C to copy. Let's scroll down to the bottom. Underneath our show win label, we write a function called function on restart button pressed, return type of void. All we simply want to do when we click the button is we want to say, hey, set up the board again. Do you want to play a game? Set up board. Hey, and save that. Our button's connected. Our winning label is connected. Our flips, no match, go back. If there is a match, it says there is a match and checks if we have all our matches. If it does, it shows our win label. Check if the animation is finished. And if it is, we do all the logic there to check if we have any pending flips or if we're maxed out on our flips. If there are, check our match. Then we have our player asked to flip. If it can flip, well, it will. If not, it will just return back. And then we add to our pending array, our flipped cards. Then up here, we're going to actually set up the board, get rid of the existing ones, clear out everything, build a new board, and then add the childs to the grid, and then connect all their signals and functions to each card individually. And then the ready function that just sets it up initially and connects our button. So the key design decisions here. So when the player clicks a card, flip requested fires, main checks the can flip. If it's false, nothing's going to happen. If it's true, we're going to append the card to the flipped cards array, increment pending flips, and call flip. So when the second card is requested, can flip goes false immediately. So no more cards are going to be able to be added. So then when each animation is going to complete, on card flipped fires, we decrement pending flips. When it hits 0, we have 2 cards. Then we check for a match. This guarantees the match check only happens once, both animations are fully done, and there's going to be no race conditions there. The game is technically now functionally complete. We can play it, but it really has no juice whatsoever. That's what our next part is going to fix. So if we save this here, and for those that follow along, you're already caught up. If not, well, the only thing we did different for our card script is we changed the setup function. We got rid of the underscore. We don't want that. We're going to separate these from the actual engine functions. And we also, in our GUI input, we got rid of our to-do delete manual call on the flip. We don't want to call the function in this GUI input. We just want to emit the flip requested. So if you still have that, make sure you delete it. So we can go and give this a try. Make sure you're in your main. We can do here is we actually click this play button. And then we're going to set this scene as the main scene. So we can select this. We can change it later. But since we're on our main current scene here, we're going to click this play button and select this current scene. And now that's our main scene. Oh, it helps if you actually spell instantiate right. Instantiate. There you go. Always autocomplete. It definitely saves a lot of headaches. Great. Let's save that. Now that we learned how to spell, play again. And we have our grid. Then we have our flip. I'm going to check another one. Flip that didn't match is a banana and a apple. So strawberry, banana. Oh, we have a banana here and a banana here. Now we have a match. Can't click on those again because they're already matched. Then we can go through and actually try to match all these. I'm not saying I'm the best at matching. Got lucky a couple times there. There we go. Apple, where is the apple? Right there. Perfect. Cherry. That was cherry as well. Orange. Orange. Now this will be our last match. So this should pop up our you win. You win. Our kiwis are matched. All of our fruits are matched. We win. Then we can play again if we like. And this will reset the board. Remember, there's a kiwi here before, but now it's an orange. Now, pineapple, orange, kiwi, it's all mixed up again. There we go. Now, we're going to add in some color transitions and then some timing so the player can't click right away. We're going to actually make sure they can see the second card a little longer. Then add in some color playing transitions so it's looks a little better when you actually make a match. So if you're interested in that, well, stay tuned. And that juice we're going to add on the next video. If you found this helpful at all or fun, leave a comment, share the video with your friends. It really helps out the channel. Tell me, what are your Godot game dev goals? What are you going to add these tweens to? I read all the comments. So please like, subscribe, and hit that notification bell. It also really helps out the channel. And thank you to all our current, past, and new Patreon Coffee members. Your generous support keeps the channel moving. Now, if you want early access to tutorials like this one, source code, or you want to suggest future tutorials, please consider becoming a member yourself. The links are all in the description. I'm Spaghetti Syntax, and remember, just finish it. Doesn't have to be perfect, and stay curious. I'll see you at the next checkpoint.